So predicates and quantifiers.
Quantifiers.
So if we had a predicate, then why are we having a quantifier? Okay. Now these are the predicates, and we have variables, we have quantifiers, universal and existential quantifier. We'll talk about them a little bit, and we are saying now we are having prepositional logic is not enough. We are saying the prepositional logic is not enough because I am saying all men are mortal, and among the all men could be Socrates also. Could be what?
Socrates.
Socrates is a man. Say for example, Socrates is a man. Can I say from these two statements, can I infer from these two statements that Socrates is mortal? I can, but not using the prepositional logic. I want to combine these two sentences because all men are mortal. Since Socrates is a mortal, therefore, okay,
Socrates
it's called modus ponens. Means that if P, then P applies to Q. Okay, we will read that later on. Just forget about that. It's called modus ponens. That means we have some statement, and from that we infer something. Next statement that I can say Socrates is mortal. I can't do it using the prepositional logic. And now I am saying all men is mortal. I could say X is mortal. Now this X is a variable, and we don't know actually what's the value. So when I say X is a mortal, I can. This is not a preposition. Why is not the preposition? Because we don't know whether it's true or false. Preposition has to be either true or
false.
Now this is true or false depending on the value of X. I am saying if X equals to God. So is this true or false now?
False.
Now it is false. Now this can become proposition if I say God is a mortal. God is not a mortal. Okay, God is mortal, it's false. We can say like that. But that means if I have X is mortal while X is an unknown entity, then it is not a preposition. Right? So we need something else. So we have to move further than the preposition. That's what's called as a predicate. What's called?
Predicate.
We have what? Predicates. So I am saying Najiba drives 6 kilometers. Now in this scenario, the Najiba is the X we were talking about, and drive 6 kilometers is called the predicate. And this X, the Najiba, is actually the subject. Okay, predicate is something which talks about the subject. Right? In any English sentence, predicate means which talks about the subject. Right? Okay. Now, what we are saying is that if we do not have a sentence where we can calculate true and false value because there are some variables, in that scenario we have the predicates. Okay? So that's why we have a predicate logic. So in a predicate logic, what we have? Firstly, we have the variables. We have what?
Variables.
X, Y, Z, which was not possible in the prepositional logic. We also have the predicate, and this is actually called the predicate function. We talk about this function in a while. This is the predicate function. Then we have the quantifiers, which we will talk shortly. Okay, the quantifiers, which will tell us about the domain. We need to know the what is the universe of discourse. For example, we are talking about problem only about the integers, right? That means our universe of discourse or domain is integers. We are talking about human beings. So our domain or universe of discourse is human. Okay? And this is called as the predicate function. This one. We talk about this in a bit. So we have variables and predicate. We do it like this. We'll talk about in a next slide this thing. And the variables can be replaced by elements from their domain, or because where from you get the variables? You get the variables only from the universe of discourse. If I say humans, you have to use Najiba, you have to use Basirat, you have to use Junaid or somebody else. I can't talk about now the dog, or because my universe of discourse is humans. So the variables which are here, they take the values from the universe of discourse or domain. ठीक है ना? Getting a little concept. So this is what is called the prepositional functions. We call them as what? Now these prepositional functions, when will they become the prepositions? I said X drives 6 kilometers. Now, is this having any true or false answer? No. Why? Because there is X. Now, I am putting, instead of X, I am putting now Juni drives 6 kilometers. But now this Juni has to be from the domain. When I substitute the X, it can be either true, it can be either false. Okay? So this statement P of X is said to be the value of the propositional function P at X. We say it's the P is a predicate at X. Okay? For example, we have P of X like this, where we have the statement X is greater than 0. X is greater than 0. Now this X is greater than 0 will give me the domain. Because I cannot take the values which are less than this. Now if I have P minus 3, that's going to be false because it doesn't satisfy the greater than 0. If I have an X value that is 0, that's again false. It should be greater than 0. If I have 3, that means true. And the universe of discourse is shown by the U, the domain. Okay? So what is the U here? Because when I say X is greater than 0, what is the domain? The domain is integers. Or we could say not even integers, because integers are negative numbers also, right? Okay. They can be positive integers. But is domain natural numbers? If I ask this question, is domain here natural numbers? Okay? Or integers? Because integers takes all the positive and negatives. And natural numbers takes only positive. So what is the domain?
Natural.
No. Natural number will give you the true answer. Domain is integer. I can take X any value, either negative or positive, but depending upon whether it is if it is positive, then it satisfies this condition. Then this predicate will become true.
True.
Okay? Otherwise, X is taking minus 3 also. X is taking 0. So it is taking the value from the domain. It's taking the value from the it is taking from the value from the integers. Okay? So therefore the domain is what? Integers shown by U. U is the universe of discourse or domain. Samjhayama? So it is taking the value, all the values. But depending upon the values, it can be true or false.
तो इसके से कोई और भी हो सकता है ना यूनिवर्सल
But if our domain is integers, we will not take rational numbers now. Okay? We can have rational numbers also. But our domain, if our domain is integers only, so then we will take only integers. Domain will tell us x क्या value ले सकता है. Do you understand? Do you understand or not? Now these are some examples, huh? Yeah. The examples of prepositional function. These are some examples. ये prepositional function की कुछ examples हैं. Now let x plus y is equal to z. Now this will be denoted by like this: r x comma y comma z. Now r is the predicate and x, y, z are the variables, and it has to satisfy this condition. Okay, and u for all the three variables be the integer. So x, y, and z can take any value from the integers. And then if I say r2 minus 1 5, is this satisfying this predicate function or not? Because you put that is 2 is x. The 2 minus 1, is that equal to 5? No, this will be false. 3 4 7. 3 4 7 is true. Why is it true? Because 3 is x, 3 is y is 4. 3 plus 4 equals to 7. X 3z. It is not a proposition. Why? Because we have to understand this. When you give a variable, when you give what?
Variable.
It should become the preposition. It was not a preposition in the beginning when there were variables, because we couldn't figure it out. Isha true is it false or true? Then it was not a preposition. But after giving what? Values. It should do what? It should become a preposition. It should give value, true or false. Right now it is still uncertain because there are again variables. So it is not a preposition. What about x minus y equals to z? Now there is another this predicate. X minus y equals to z denoted by q x y z with u again as integers. So I am saying 2, negative 1 and 3. Because negative minus y plus, that is true. 3, 4, 7.
4.
Because 3 minus 4 is not equal to 7. X3z.
Again.
It is not a preposition. Get it? Nice. So what is a predicate? We come back to it. We come back to this thing. What is a predicate? What is a
Predicate.
So we are saying following sentence: x is greater than 3, x is y plus 3, x plus y equals to z. So when will they be true or false? When will they be true or false? When you give the value of x. When you substitute the value of x. And where from you get the value of x? Universal discourse. So if I say x is greater than 3, what is x? What is greater than 3? Predicate. Okay? Now we could say it's affirmed, that means it holds true. If it is true, okay, if we substitute the value of x and it is true, we say it holds and it affirms, this predicate affirms. And if it is denied or does not hold, or it could be that it is not true. Do you understand? This is again the same. So if you want to write in predicate logic this thing, x is greater than 3. So how you write it? You say simply p and you put x in the parentheses. Right? So this is how we write a predicate. Okay? So this is the functional symbol for predicate. So this is actually called as a predicate function when you write like this. It's a predicate function. It's a functional symbol. So there could be unary predicate like father x. Okay, it could be the brother, x is the brother of y, the binary predicate. There could be the sum, like x plus y equals to z. There could be the n-ary predicate. Okay, there could be n-ary. That means there is some relation, there is some association, relation between these variables. To tell us, n-ary means which has a multiple, more than 2. Okay, n can be anything, 2, 3, 4, n-ary relation, and so on. Now this is the propositional function which we are discussing just. Okay, so if we have a still form p x1 x2 xn, okay, it's a propositional function. And where x1, what are the x1 x2? This it's called as an n tuple. We call them as what? And p is the predicate. P is the variables inside will tell us what values it will take and it should satisfy that function. That's with the
Function.
So now this propositional function can evaluate to true or false. It can take one or more arguments, okay, and so on. When you assign the values to these predicates, this is an example of it. This is the q x y z, and we have a statement actually like this: x square plus y square is z square. So if we have the value 3, 4, 5, is this true or false? Can you tell me? Because it is x square plus y square equals z square. That is 3 square. Do it on the copy. That means 3 square.
9 plus 16.
3, yeah, is equal to 25. It's false.
2 n.
Okay?
N k.
Similarly, there is 2, 2, 3. Calculate this. 2 cos square plus 2 cos square is equal to 3 cos square. 4 plus 4 is 8.
8 is
Is 9. 3 cos square is
9.
Is 8 equal to 9?
No.
Again false. So then we can see how many predicates can this be true. Now make this true. We have to calculate, try to figure out, give the value of x and give the value of y.
जो ऊपर वाला है ना,
Yes.
ये false कैसे है?
कौन सा?
X square plus y square, 3 का square plus 4 का square.
3 का square is how much?
9.
9.
4 का square?
16.
16 plus 9 is?
25.
So it is true.
हाँ समझ गई.
Okay. So similarly, we have to put values into it and figure out how many there could be. So that means this predicate is not true for only one value. It could be for multiple values. Like I say, man is mortal. X is mortal. Now I put up Jamila or Razila or Barira or whatever in it. They are all mortal. So they will be all true. So there could be multiple values which can be true. Right? Now this is the answer of this previous question. Okay? If you already validated.
Universal discourse.
So what is the universal discourse? The previous value, where we have x square plus y square is equal to z square. Can you say x is equal to red? It doesn't make any sense because we have the x square, so it has to be some kind of integers, right? So we can't put up the blue into it. Or can I put man in? Can I put the Basirat into it? No. Why? Because it's not the universe of discourse. The x and y, they have to take the values from the universe of discourse and so on. And not necessary that each variables among this n tuple, this is called n tuple, all have the same universal discourse. Not necessary. You could have these three, for example, RGB, and C is the color. C is what? Now they can take from 0 to 255 values because RGB values they can take from 0 to 255 values, right? And C tells us which color, red or blue or whatever. So this is like the alphabets, okay, words, okay, and these are the integers. So that means the n tuple, in the n tuple, not necessarily all of them have the same universe of discourse. They can have different universe of discourse. Like the C here is like red. Say for example, this is true because 2500 R, B, and G. R value full 255, blue 0, green 0. That means this is red color. And in this case, this is R, this is B, and this is G. Okay. Now red is 0, blue is 0, green is 255. So it has to be green. Otherwise, it false. This is why is this false? I don't know. This is false. This has to be true.
Sorry, RGB.
RGB. Yes, RGB.
RGB.
Sorry, RGB. I think RGB. Sorry, RGB. Yes. That's the problem. This is the RGB. So it's a blue value. It's actually blue. It's actually what?
Blue.
Blue is 255. So it has to be here blue, not the green. Right? Because R, G, and B. You can mix up these RGB to get up different colors. If the red is full, 255, G is 0, B is 0, it's gonna be
Red.
If it is like R is some say 25, B, G is some 130, B is some 220, whatever. So it creates a mix up of colors. अगर एक कलर फुल है, जैसे ये वाला कलर फुल है, B फुल है, लेकिन ये 0 0 है, तो ये तो ब्लू होगा ना? तो ब्लू आपने फुल कर दिया ना, बाकी कलर 0 कर दिए, तो ये तो ब्लू होगा. So that means it's false. So what is the universal discourse for RGB and C? Question, answer. What will be the universal discourse of RGB? It will be integers. In fact, it will be only from 0 to 255. It cannot take more than 255, it cannot take less than 0. So universal discourse has to be from 0 to 255. Positive integers from 0 to 255 has to be the universal discourse. It cannot take 279 or something values. Now what is the C?
Red, blue,
Color.
and
Red, green.
Yeah.
What color?
Not only red, blue, and green, can be other colors. Magnet can create a mix of colors.
सर फिर आपने क्यों वहाँ पे बोला 255
Burgundy, sienna, penna.
अगर आपने कंबाइन किया ना, जैसे आपको मेजेंटा बनाना है, so you have to color mix up the colors.
Lavender.
ठीक है?
Blondie कोई है.
अब आपको पिंक बनाना है. इन्हीं तीन कलर्स को मिक्स करके सारे कलर्स बनेंगे ना.
सर बोलिए आपने कहा ना वो इससे पहले ये नंबर है इंटीजर क्वेश्चन इसका वैल्यू 255
0 से 255 तक आता है.
Color values.
अब डिपेंडिंग जैसे R का 0 से 25 तक 0 means nothing, 25 में मैक्सिमम रेड. ठीक है? तो कितना ये डाला, कितना ब्लू डाला, कितना ग्रीन डाला, उससे निकलेंगे बाकी सारे कलर. So C will not only have the red blue color but all the colors. Okay? Now a predicate becomes a proposition when then you fix a value to it. Okay? But there is another way. That is the next. Now look here. Either we can say, when you say quantify means how much na kind of thing.
Double absolute.
When we are saying we want to quantify, we want what? That means we are talking about universal discourse. यूनिवर्सल डिस्कोर्स में क्या सारे इसमें से ट्रू है? जो मेरा प्रेडिकेट बता रहा है क्या वो लागू होता है ऑन द ऑल ऑफ द एलिमेंट्स ऑफ द डिस्कोर्स और फ्यू? सो डिपेंडिंग ऑन दैट वी हैव टू क्वांटिफायर्स, यूनिवर्सल एंड एग्जिस्टेंशियल. द उल्टा ई एंड उल्टा ए, उल्टा ए एंड उल्टा ई. So if you say ulta A, that means what? For all. That means for sub K. And if we say this one, this is for some. This is for कुछ के लिए. इसमें कुछ के लिए का मतलब ये होता है कि at least one. अगर एक भी बंदा ट्रू हो रहा है तो ये ट्रू है हमारा. ठीक है? ये सिर्फ फॉल्स तब होगा जबकि सारे नहीं सेटिस्फाई करेंगे. यूनिवर्सल डिस्कोर्स में सारे के सारे नहीं करेंगे. यानी कि जैसे मैं कहूंगा आई विल पुट ए मार्क टू दिस क्लास, अगर डिबेट में एक भी आप में बच्चे से किसी ने लिया हिस्सा. बस में आ रहे, अगर डिबेट में आप में से एक भी बच्चे ने हिस्सा लिया तो आई विल पुट ए ग्रेड ए ऑन दिस क्लास. अब 2 भी ले सकते हैं, 4 भी ले सकते हैं, 10 भी ले सकते हैं, या सारे भी डिबेट में कमर्शियल ले सकते हैं, लेकिन कम से कम एक लेना चाहिए. अगर 0 ले रहे हैं, कोई भी इस क्लास में नहीं आया, that means I will not grade it. So that means it's false. Otherwise अगर एक भी बच्चा आ गया, it is A. That is the for sum existential quantifier. So it's quantifying the discourse. अब मैं यही स्टेप बताऊं दूसरे तरीके कि भाई मैं आपको ग्रेड 1 तब दूंगा जब आप में से सारे के सारे बच्चे डिबेट में हिस्सा लेंगे. अगर एक भी एब्सेंट रहा तो फॉल्स है. सबको लेना पड़ेगा निश्चित. अगर एक भी फॉल्स हुआ तो फॉल्स. तो ट्रू कब होगा? जब सारे के सारे. So these are two quantifiers we have, existential and by that also we can make it true or false. We can make it true or false. These propositions. So the first thing is the universal quantifier shown by the ulta A. Okay, and predicate is P of x is true for all values of x in the universe of discourse. So that's why we call this as for all x. For all x. अगर universal discourse finite है, यानी कि कुछ ही elements हैं, so it will be the and of all, conjunction of all. It will be the conjunction of. So it will be the conjunction of whatever. If this has A, B, and C in the predicate, so this means P is P of A and P of B and P of C. It's a conjunction because we know and is true only when all the true, when all are true. True. Right? So जो इसी का अगर हम बताएंगे फिर existential उसमें क्या होगा? Or. Because all is true. If even one single is true, it is all is true. So it's the disjunction of the predicates, individual predicates. Okay? So that's why it's saying the conjunction of this P of n1 and P of n2 and so on. Because and will tell us it is about all of these guys. And it is saying that this predicate x must take a discrete mathematics course. So this is a predicate. X must take a discrete mathematics course. That means X can be Basirat or any boy or girl or anyone, right? And this is the predicate is must take a discrete mathematics course. And let Q of X be the predicate. X is a computer science student. X is a computer science student. Now this is the subject and is a computer science student is a predicate. Now for both of these statements, what is the discourse? It will be the ICSC students. Islamic College of ICSC. होता है एक चीज़ लिखना I see IS हो गई
Islamic College of Science and Commerce.
Islamic College of Science and
Commerce.
it could be this either this predicate or this predicate.
The Universal for all.
Now if I say every computer science student must take a discrete mathematics course.
For all.
For all.
See, the first one was
Or
that X must take a discrete mathematics course. This is the first statement. Who is X? Any student of
Islamic College.
Computer application student of Islamic College Science and Commerce ICSE. But it should be the only the computer application guy, not the other commerce others, because we have all the streams here. So let's take so X will not be Islamic College Science and Commerce because that will take other students also. It should be the computer application department.
Computer science. Yeah.
This is my universal discourse. Computer application department. Now here I am saying the first statement is saying X must take a discrete mathematics course. Who is X? It could be any student from the BC or MC, and he or she has to take this mathematics course. The X can be anybody. The second statement I am saying is X is a computer science student. X is what? अब ये दूसरा जो हाँ तो इसमें हम अब यूनिवर्सल डिस्कोर्स ले सकते हैं पूरा ICSE क्योंकि मेरा X अब जो है वो आ गया कौन कंप्यूटर साइंस वहाँ पे इस प्रेडिकेट से जो बाकी स्टूडेंट हैं वो फिल्टर हो जाएंगे Now this statement every computer science student must take a discrete mathematics course. This is a question for you that every computer science student must take a
Discrete.
if I say X is a computer science student, what is the predicate for that? Q of X. Okay, Q of X means that X is a computer science. Now that X has to take mathematics course, that means that is P of X. That is what? And if you have to write that every computer science student must take a discrete mathematics course, you have to use the universal quantifier. Okay? You have to use the universal quantifier. How will you write this? Write. How will you write this? Tell me. जबान बताओ. लिखनी क्या जरूरत है?
add नहीं सकते हैं तो दोनों का
We have the क्या करेंगे?
For all. Yeah.
Definitely. If you say P of X and Q of X, that is what it is. But what it we हमने कहा it's a conjunction. The universal quantifier is actually the conjunction of the individual predicates. Okay? To give us a complex predicate that every computer science student must take a discrete mathematics course. Logically, we can write it like this: P of X and Q of X. But how we write it using the universal quantifier?
डालने की फिर बड़ी ब्रैकेट में दोनों चीजें
So if I say for all,
फिर ब्रैकेट
For all Q of X, if you use P
for
of X.
all X, Q of X
Implies
implies to P
P
of
of
X.
X.
For all X, यानी कि सब X के लिए, and universal discourse is ICSE, जो भी ICSE में स्टूडेंट है, अगर वो क्या सेटिस्फाई करता है Q of X. Q of X means X is a computer science student. Q of X satisfies that it's a predicate. Which predicate? X is a computer science student. If it is so, for all X belonging to this, then they have to use they will imply this predicate. That P of X. What is P of X? What is X must take a discrete mathematics course. This is how we apply this. Now there is a statement: everybody must take a discrete mathematics course or be a computer science student. इसमें or be a computer science student. This is your write this down. Write in your home. Write this down. Express the statement.
तो इसको ये एक्सप्रेशन बनाना है
ये बनाना है इस तरीके से. Everybody must take a discrete mathematics course. Everybody. जब everybody आता है, it means universal quantifier. जहाँ भी आपको कहीं पर ये आएगा everybody all, ठीक है ना? आपको आएगा all या everybody, यानी कि हर एक के लिए जब कोई चीज true होगा, तो उसमें क्या लगाएंगे आप? Universal quantifier. For all X लगाएंगे उसमें. Or be a computer science student. या तो उसको डिस्क्रीट मैथमेटिक्स लेना है या तो उसको कंप्यूटर साइंस लेना है. Everybody must take a discrete mathematics course or be a computer science student. Here is the answer. For all x, for all q of x or p of x. या तो ये होगा या तो क्योंकि और आया ना बीच में, तो और को हमने और लगाया डिसजंक्शन. ठीक है ना, समझ में आ रहा है? क्लियर? Now you can say are these statements true or false? अब इसके बारे में बताओ. Are these statements true or false? क्या ये ट्रू और फॉल्स हो सकते हैं? हो सकते हैं. They can be either true or depending upon what the students are doing. Now what about this? Express the statement for every x, for every and for every y, x plus y is greater than 10. For every x and for every y,
Universal है ना?
exactly. Whenever there is for every or for all, so that has to be for all. Universal quantifier. We have to use what? Universal quantifier. For every x and for every y, x plus y is greater than 10. So how you will think about it? Think about it.
For b sin x.
For every x, for every y,
Read this.
for every y.
So you have a predicate. You have a predicate what? X comma y, and we have a statement. Predicate is x comma y, and statement is x plus y is greater than 10. This is our statement. This is our what? And predicate is this. Predicate function is this. बात टाइम करने से क्या होगा? P x comma y. This is my predicate, where x plus y is my statement. And universal discourse is what? U is what?
Yeah.
ठीक है जी? Is this clear? So what I am saying, for all x, for all y, predicate x comma y. Now look here. क्योंकि predicate x comma y has to satisfy the statement. Has statement what? X plus y is greater than 10. This is the statement which is to be satisfied. This is my statement which is satisfied by for all x and y. So to make, because predicate p x comma y tells us about this statement, okay? But we have to write now this for all x and for every y. There are two, for every x, for every y. So you say for every x, for every this predicate. And this predicate will satisfy this statement. Does it make sense? समझ आ रहा है? ऐसे क्या है? और in shorthand we can also write it comma here, huh? For x comma y. So no need to write twice for all. We can say for all x comma then predicate p x comma y. Predicate p x comma y has to satisfy some statement. There is some statement. The statement is x plus y is greater than 10. You have to understand that this predicate has a function. This function has some statement on the back. This has to be satisfied. For what? For becoming true or for becoming false? Because when it takes the x and y values, we have to see whether it is true or false. Does it make sense?
Yes, sir.
Now there is existential quantifier. I think we will stop here. Seems you are bogged down. Okay? That's all for today. We will see you next time with the existential quantifier, and you will do the ALP programs.